ZM everyone. How are you all? How was the day? How are you all doing? Okay, so let's start with the event itself. So first of all, welcome you all and thank you for joining. And let me first of all tell you why we have started this event, Weekends with Web3. So the main purpose is to chill out and talk to the fellow builders and know what they are building, what they are doing. A very casual kind of event. So it's not like an event. It's like a community hangout kind of thing. So that's something to point out. And today we are thinking about discussing about Ethereum accounts and what are the different types of accounts in Ethereum, how transactions work, and a brief intro to account abstraction. So let's begin. Just a second. think my screen is visible now. Okay. So first of all, if we oversimplify what accounts are in Ethereum, so they are like your bank accounts. And what do you do with your bank accounts is your bank accounts hold your assets, your money. Sometimes you use lockers inside banks. So all of that are linked to your bank accounts. So somewhat accounts in Ethereum are like that. So with your accounts, you store your assets, you store your cryptocurrencies, and this is like a basic high level overview of what are accounts. So here you can see, using an account you can interact with the smart contracts. So what are smart contract? Smart contracts are the logics that are working on the blockchain. So in case of blockchains, all the logic is stored on the blockchain, written in the form of a smart contract. And in case of Ethereum, we use Solidity mainly for developing smart contracts. So you can see here we use our account to interact with various smart contracts, and using those smart contracts, we make some transactions, and transactions do what they do some change. They update the state of the blockchain data. So that's a very basic overview. Now, there are basically two types of accounts in Ethereum. So those are externally owned accounts and smart contract accounts. So externally owned accounts are something that most of us would have seen, heard, or used. So if you have heard of MetaMask, MetaMask is an example of a digital wallet that creates externally owned accounts for you. So let's see how externally owned accounts work. So most of the externally owned accounts, what they do is, when you create an account, you are given a passphrase, and using that passphrase you create a public private key pair. We will get into that in much detail. So if you haven't created a MetaMask wallet yet, I will just quickly guide you, just for even if you have created some time ago and you don't remember exactly what I'm talking about. You can just go to the MetaMask website, and here you will see the option for your particular browser. Okay. So it works like it is added to your browser like an extension. And why as an extension? Because whenever you want to interact with the blockchain, you always need to sign the transactions. And when something is that, because when like anything you want to any interaction you want to do with the blockchain, you need to sign the transaction. And when this would be very frequent when you are because there would be many kinds of interaction with the blockchain. So you don't want to go to some website or launch some application and do that again and again. So for that, for our ease, it's an extension. Now let me just put a very vague password: 1 2 3 4 5 6 7 8. Okay. Okay. Now click on secure my wallet. Always do secure your wallet. Now you see, we are going to get a 12-word secret recovery phrase. Now, just keep it in mind that what I am doing right now is extremely dangerous. I am streaming my screen, and you all can view this passphrase, this recovery phrase. And if anybody knows this recovery phrase, they basically have access to your wallet. And if they have access to your wallet, they have access to all your assets. So you are gonna lose everything. So never do this. But just for the sake of explanation and showing you the demo, I am showing you like this. Okay, so that's a 12-word phrase. Just let's write it down somewhere. And what I'm doing right now, this is also very wrong. putting it locally in my computer. So don't do that. You might be thinking till now you have said 4 times that what I am doing is very wrong. And why are you doing it again and again? See if you can directly copy it. No. So what I will do is I will take a screenshot of this. I think I can't even do that right now. So for saving time, all you have to do is you have to keep it safe somewhere. Okay, this 12-word passphrase. This is called your secret recovery phrase, or in terms of cryptography, you call it your mnemonics. Okay. So you have to fill it over here, and once you do that, your account would be created. So let's leave it over here. Write that voice. So I have already created one account, and I have a lot of metrics on the testnet, of course. So you see, once my account is created, this is my account name and this is the account address. Okay. And you can see that I have multiple accounts over here. And the amazing thing about this is that using just one mnemonic, you can create a large number of accounts, any number of accounts you want. So let's see how this all actually works. First of all, I would like to tell you a little bit about BIPs. So BIP is basically called an abbreviation for Bitcoin Improvement Protocol. So proposal, Bitcoin Improvement Proposal. And what that does mean is, like, just in case of laws, we have some bills to improve our laws and rules. So just like that, in case of in this Ethereum or Bitcoin organizations, people propose some bills, and these are called improvement proposals. So one such proposal is BIP 44. So basically, Ethereum and MetaMask use BIP 44 only for creating these mnemonics and private key and public key. The whole account creation stuff is handled by using BIP 44 standards. So how does that work? First of all, we use a English word list, and from there we get a 12-word recovery phrase. And basically, this could be any 12-word. It doesn't have to be anything specific, but you can just say there is a large list. I can actually show you. This word list. See this huge word list. So basically, there are 2048 words over here, and there could be 2048 different combinations of these words used to create your secret recovery key. So that's really a large number if you think about calculating it. So how let's get into how your account is created. First of all, you saw that 12-word recovery phrase over there. So that is basically your mnemonic. Then we add something called a deviation path. So don't get much into this, but it is something like an index. So what here this means is that this 44 is basically this BIP 44. Okay. And this 60 is the chain code for Ethereum. Okay. And this 0 over here, this means that this is 0th index, and you will understand much more why we are using indexes when I will show you a visual representation of that. Okay. So once we combine these two, and there are some kind of hashing applied over them, so we get a private key from that. And this is an example of a private key. So till now, this whole thing that you saw over here, anyways, the deviation part doesn't matter, but this private key and this mnemonic, These two are the stuff that you never ever have to leak to anyone. Okay, you lose these and you are gonna lose everything that you own in your account. So just keep that in mind. Be very careful with your private key and your recovery phrase or your mnemonics. Now, on your private key, there is something called elliptic curve cryptography. It's a very complex algorithm used in cryptography. So let's don't get much into that. It is used to create a public key, and this is a trapdoor function. So what's a trapdoor function is, you can go this way easily, okay, but you can't come this way. This is like computationally not feasible at all. So this is where the security aspect of cryptography lies in here. You can share this public key, but you can't ever share your private key, because you, with this public key, nobody can reach here, but from here you can get to this public key. And public key is something which you generally share. If you have ever heard about RSA cryptography, so there it is similar concept. So any kind of asymmetric cryptography has this public private key pair. Now we have the public key over here. What we do next is 20 bytes of this public key are passed through this Keshak 256 hash compiler. And what happens is, this Keshak 250, after hashing it using this Keshak 256 algorithm, we get the account address. And this is the address that you just saw over here, this address. Now you see this is account 2. And I told you that using one mnemonic, we can generate multiple accounts. So how does that happen is, you see this index I told you about. We keep increasing this index. Just we keep changing this index, and according to that, we get a whole different private key. And each private key generates a different public key, and that in turn generates a different account address. So you see, by just changing these indexes, we are getting multiple accounts. And there is one more thing that I want to add up is, in case of externally owned accounts, your account is very equivalent to public private key pair. So an account is basically equivalent to key pair. Okay. This is something to keep in mind. Now we are over here. Let's see some example. Say, let's generate a 12-word phrase over here. Okay, we got a 12-word phrase, just like what I showed you. Now let's see over here. You see, using these indexes 1, 2, just we are varying this thing, the last index value, and according to that we are getting a completely different set of addresses. The public key and the private key, everything is completely different by just changing this value. So you can't just say, like, if you are thinking that we are just changing one digit, and that might not generate a very different address or a very different key. So that's not the case here. It's very different. There are lots of random prime numbers used to generate this. So even a difference of 1 bit matters a lot. So now let's try to show some visualization. So here we just generated a small machine that generates a lots of passphrases, secret recovery phrases. These are all 12-word phrases. Okay. Now let's do something. Add an index. And even before adding index, let's do one thing first of all. We have generated this secret recovery phrase. Now let's keep it somewhere. Let's assume that this is our 12-word seed phrase, recovery phrase. Now, okay. Let's connect this to mnemonic and generate a private key. So see, we have got a private key over here. Now let's do something. Add an index 0. So you see, when I enter 0, there's no change over here. It's the same private key. That's because when you create an account using a recovery phrase, it generates, it automatically appends the 0 phrase. Like I just show you in that website. Now let's increase it. See how much it is increasing just by increasing one index. That's clear, I guess. Now let's create an account. Okay. Look at this address. Just using, I will also show you the public key. Sorry. So move this, make it very clear. This is your private key. And this is your public key. And this is your account address. Basically your account. And as we keep increasing this number, this index, see how much they all would change. Just one change in the index. So I think it's a bit clear to you all now how this whole account generation thing works in case of externally owned accounts. Okay, then this is all for externally owned accounts. Now I will hand it over to Samir to explain you about transactions in Ethereum.
Thanks, Sudhanshu. So yeah, let's get started. I'll present my screen. Yeah, is it visible?
Yep.
Okay. So hey everyone, hope you're having a good day. So welcome to the first episode of Weekends with Web3, and as the agenda goes, I'm gonna make you understand the life cycle of transaction in the next few minutes, and surely it won't take much of your time. So together with my partner Sudhanshu, we are on a mission to spread knowledge and excitement about Web3 technologies in Bangalore. So join us on weekends as we conduct these engaging events, and we'll also have an IRL event soon. So here goes the roadmap. So we all make transactions, right? Whether you're making your first DApp and connecting it to a wallet, or buying an NFT, or trading illegal stuff online on black markets. If someone is doing that and really making huge bucks, tag me in, please. So here's the roadmap, and it pretty much sums it up like the transaction initiation, broadcasting, mempool and transaction prioritization, block inclusion, and at the last, consensus and confirmation. And don't worry, I'm going to go over all the topics in short. So next we have transaction initiation and broadcasting. So users, right? That's you and me who want to make the transaction. So obviously, when making a transaction, we need two things: the amount and the address to whom we are going to send it, right? just like UPI, we need a phone number and amount, but far better. So where we gonna do like interact and do stuff with this thing? Wallets. Wallets are like MetaMask make this possible. It's a digital wallet that stores the fund, and we can make or say sign transactions. So like when the transaction is made, not just we but anyone can view it on the respective blockchain on services like Etherscan, Polygon Scan, and etc. So I'll show you the demonstration now. So like this is my MetaMask wallet, and I have 2 accounts on it. Like as Sudhanshu said, we can create as many accounts as we want. So we'll copy the address of a second account, and now we'll send some ETH in our second account. I'll paste the address here. Let's say we're sending.
Bro, send me some mainnet, please. Send me some mainnet.
I can send you as many testnet. So yeah, so this is the gas fee, and we are sending 0.00001 ETH. Confirm.
Meanwhile, just adding this up, testnets are for development purpose and they cost you nothing. They are just a simulation of the original transaction on the mainnet. So when you are developing any dApp, you first of all want to check everything and test everything on the testnet, and once you are done, you bridge everything to the mainnet.
Yeah, that's right, Sudhanshu. So as you can see, the transaction is completed, and we are shown a success here. That was 16 seconds ago, and this is the transaction hash that I'm going to talk about in the future. This is the amount of funds we are sending, and this was the gas price. So next on the agenda we have.
And just to add up one more thing, gas is basically a unit of computation. So why we need gas is because of two things. First of all, there are validators who are working to validate your transactions. So somehow we need to incentivize them. And the second thing is that it is also for spam protection. So if somebody keeps on sending some transactions, so it can result in a denial of service for the other users. So we don't want that. That's why every transaction costs something. And that's called gas. That's measured in terms of gas.
Yeah, that's right. So next we have mempool and inclusion of block in our list. So I'm going to take a bus analogy to make you understand the concept of mempool, nodes, miners, and the gas fee. And at the end, how can we obtain the hash? So mempool serves as the waiting area in the blockchain bus station analogy. So where transactions wait to be included in a block. Like transactions, we can relate them as people with faster movement, paying more fee, have a higher chance of being prioritized and included in the next block. And next we have nodes. In the bus station analogy, we can take nodes like the ticket officers, taking note of transaction details and managing the flow of transactions. They validate transactions, ensure compliance with network rules before allowing them to enter the waiting area. That is the mempool, right? So, and next we have other two things. These are miners. They do the hard work. So miners play the role of bus drivers. So they receive both the block subsidies and the transaction fee. Transaction fee being the gas fee, as Sudhanshu explained, and having people on board. That is the transaction onto the bus. Buses being the block. So they are incentivized to prioritize the transactions with higher fee, especially during the time of high network congestion. And yeah.
Also, one more thing. In case of there are two kinds of consensus that are most popular right now. Proof of work, that is in case of Bitcoin, and proof of stake, that is in case of Ethereum and other chains, many other chains. So here that we are seeing miners. In case of proof of stake, these are called validators. That's something to point out. Continue.
Yeah. And next we have gas fee and hash. Gas fee correspond to the ticket price in the bus station analogy. Like transactions with larger sizes of faster movement, like pay more for their ticket, increasing their chances of being included in the next block. Miners receive these gas fee as an incentive for including transactions in the blockchain. So yeah, that's it. That concludes the mempool and inclusion of block. So and at the last we have consensus and confirmation. So like in crypto network, Creating a crypto network comes with challenges of validating transactions, like without relying on a central authority, right? We don't want any of that. So instead, we rely on a large group of people who are incentivized with native currency to prove transaction validity. So the major two ways, like Sudhanshu said, are to validate transactions are through proof of work and proof of stake. In proof of work, miners compete to solve a complex problem, maths problem, like a training race. Like, so whoever solves it first like gets the chance to add the block in the blockchain. And in proof of stake, the stakers lock up the funds in a smart contract and get chosen to publish new blocks through a lottery-like system. You can understand it like that. So once a transaction is finalized, it cannot be altered. So this is also known as finality. This ensures that the transaction has gone through and can't be altered now. So at the end, I would say that's it, folks. I assume you would have got the idea of how transaction works. And please join our Telegram guild group to hack on some projects, and you'll also get updates about the events and can also get the chance to win airdrops. So yeah, that's it. Thank you. And
Uh,
also, I forgot to show you the transaction street. So this is kind of like a mock-up of the mempool and inclusion of block. So on the right we have the Bitcoin, and on the left we have the Ethereum. So yeah, each person represents a transaction, and each shop represents the type of transaction. Like here we have Uniswap, then we have Tether, USDC, MetaMask, and in every block there's some size, like how much transactions it can take, and there's the confirmation and everything. This is a good visual representation of the mempool. And below we can see that there's a fee line, like greater than 75,000 V. Only those folks are accepted to give their transaction onto the bus.
so basically, how it works is whenever we initiate the transaction, those go into the mempool, and with every transaction, there is a gas price listed that the initiator of the transaction is willing to pay for the transaction to succeed. What happens is that sometimes if you are trying to use less, like you have some time, you don't want to transaction to get added to the block quickly, then you can go ahead and you can pay a little bit less or less gas fees. What happens is that in the each validator or miner node, what they do is that they arrange the transactions in the mempool in such way that they get the maximum benefit out of it. So you can understand how they are going to do that. So if you are paying less gas fees, you won't get picked earlier. It might take some time. Sometimes it takes like a day to get for your transaction to get picked, but it eventually gets picked unless you are not paying really low. So that's something to add up. Yeah. So this was a little bit about the transaction cycle in case of blockchain in general. Now let's get into account abstraction and smart contract accounts a little bit, not very much in depth. So just one last time.
All right, people, let's do this one last time. All right, people, let's do this one.
Okay. I just wanted to show that I'm a Spider-Man. That's it. Okay, is my screen visible now? Cool. So this is something that we just discussed about externally owned accounts, and we saw something that this account is closely coupled with the key pair. So basically, whoever has the private key of that account is basically the one who owns that account. There is a major issue with that. Say somehow you lose your recovery phrase. What will happen to all your assets? You are going to lose everything just because you lost a 12-word recovery phrase, and that's actually very scary. That can lead to a lot of anxiety, because when people who are new to blockchain, they are when they know that they can lose this much just by a small mistake like that, and there is no way that you can recover your account once once your recovery and private key is lost. So that is not something great. Not only that, if somebody somehow hacks into your browser somehow, because this is an extension, and gets your either recovery phrase or your private key, they can transact any amount or any asset from your account without your permission, because now they basically own your account. That's something that we are like that's not an expected behavior, because people who are coming to web3 are current users of web2, and in web2 there are lots of security. There is two-factor authentication, there is Google recovery methods, there are like a lot of ways just for handling this problem. So we can't expect people to just onboard to web3 if we don't provide them the similar user experience. So that's where account abstraction comes in. And just as I explained you BIP, we have EIP and ERCs too. So EIP is basically Ethereum Improvement Proposal, and so the 4337 standards handles the account abstraction. Now, how we see accounts in account abstraction is a bit different. First of all, I explained you about smart contracts in the beginning. They are the logics that run on the blockchain. So every contract has an address. So what we can do is, in case of externally owned accounts, nothing is present on the chain. That's why externally owned. Everything, your public private key pair, both are externally stored in your wallet. Nothing is on the chain. Also, what is the meaning of a valid transaction? That is hard coded in the protocol of Ethereum blockchain. That's something we called EVM, Ethereum virtual machine. So that is the machine that computes or validates all the transactions or stores all the transactions. So there, the logic behind a valid transaction is hard coded. That is not the right way to go about it, because people have different needs, and according to that, their account should be different. So that's where the smart contract accounts come in. And here what we do is that the smart contracts have the properties of accounts, and they are not basically dependent on some public private key pair. They are more of like very customizable. So for one example, I can tell you that you can create a smart contract account using your Google account. So you can basically go ahead, log in with Google to a smart contract account, and your account address would be paired with your Google account. So that's a very high level overview. And here, even if you lose your you lose your signer key, that doesn't mean that you have lost your account. There are lots of ways to recover. You can recover it using your email or something. So that is the kind of flexibility that comes in with smart contract accounts. You can decide that what a valid transaction is. For example, for the how Samir showed you the current transaction works in case of MetaMask. So all you do is you sign a transaction and the transaction goes. But what if somebody else has your private key and they try to send asset from your account? In case of even in case of UPIs, you see, even if somebody if somebody pays a big amount, you get an OTP, and only when you verify with your OTP, then that transaction goes further. Something like that, like two-factor authentication should be present. So here in account abstraction, we have that. We can integrate something like a external authenticator to sign whenever you want to sign a transaction. You can be one of the signers, and you can appoint somebody else or a security application to sign the other transaction, to be the other signer of the transaction. And only when you both have signed, then only the transaction is going to go to the mempool. So this is how it can prevent frauds also. So here I have mentioned something. Like one of the great features of account abstraction is it enables us to use social recovery. So even if you lose your account passphrase or say security key, you can use some recovery service. Say you set up your Gmail as your recovery service. You can use that to recover your account. that's something that we want. And the fraud monitoring I just explained you using multiple signatures. So the concept is called multi-sigs. Multi-sigs means that for every transaction, you multiple people need to sign a transaction. Like, about lockers in banks. So how the lockers in banks work is that one key is with the bank staff and one key is with you. So only when both of you are together and you both put the key in the locker and unlock, then only the locker you can get your asset from the locker, something like that. Then there is session key for games. So as I told you that for every transaction in externally owned accounts, you need to sign it, and there is no way to club multiple when you are playing games there are multiple. Say you want to pay some amount of gems to buy this stuff, and after doing that you want to add that stuff, that gems to your account. So these are two separate changes, and these two in externally owned accounts will need two transactions. But with account abstraction, we can club them together in a batch transaction and sign all together. So this provides a better user experience. So that's all with account abstraction, and there is a lot more to explore in account abstraction. So I am just giving you an introduction and a kind of overview what it is. And if you find it interesting, um, you can either DM me, you can go ahead and look for yourself. There are a lot of resources available regarding account abstraction. Read those blogs, understand how they work. So yeah, this is for account abstraction. One more thing that I wanted to add up is I forgot mentioning about that using when I was explaining EOAs. So in case of MetaMask, I told you that using one mnemonic, you can generate multiple accounts, and your mnemonic is your recovery phrase. So say you deleted your MetaMask, and then you used that recovery phrase to recover your accounts. What will happen is that when you first recover, you will be shown only the first account, and the other accounts won't show up. That doesn't mean you have lost them. You just have to uh wait, yeah, you just have to go and try to add another account. And when you will create another account, only the name of that account would be gone. So it would like, say if I have deleted Zoom, it would come something as account 4, but all the assets that were associated with that account would be recovered. Another thing was that the password for your wallet is not stored on chain. That is something that is stored locally inside your wallet's cache. I think I have made everything clear, and if you have any doubt, you can ask it in the comment section. I will wait for a second. Okay, I guess there are no other doubts. So now we have Polygon advocate Samir Kashyap with us. Hi, Samir.
Hey guys, you hear me?
Hi. Yeah. How are you?
Yeah, doing okay. How
Yeah,
about you guys?
great. Sorry for bringing you up on Saturday.
No problem.
Yeah. So, guys, Samir is a Polygon advocate. He's been with like working with Web3 for a long time now, and he has been MLS fellow. So he has pretty much a lot of experience in this domain. So Samir, you want to share something?
Yeah, so just wanted to sort of introduce a growing trend in like Web3 and for a few minutes, sort of just maybe make people curious and see what they're interested in. So just wanted to bring up this concept called ReFi, which is like the full form is like Regenerative Finance, just like DeFi, and the core concept is revolves around the concept of like climate change and how you can sort of create impact for it using blockchains especially. So to make it like very simplified, I guess there are refi, the core concept of refi has been there even before blockchains. The way which it works is there uh, there are companies out there who produce a lot of carbon emissions, and they often cannot offset, or like by offset I mean they cannot remove it remove it from the process or reduce it because it would stop their manufacturing or like disable them from manufacturing the products that which is what they sell. So instead they will give that job to someone else, and they will claim it to be their reduction. So if I am a company and I give Sudhanshu task like grow these many trees so that they absorb all the carbon I produce, so then that is sort of a way of exchange, and this is certified through something called a carbon credit. In the Web2 world, a carbon credit is certificates, but the but there is no central authority right now, and all of it is voluntary, done through voluntary markets, and that's why that is where blockchain comes in to sort of fix some of the problems that are traditionally present, such as lack of transparency, and then overselling, overusing the same carbon credit certificates. So using tokenization techniques, we can sort of solve some of these problems that are present in the current Web2 space. And ReFi as a space within Web3 is sort of taking off quite a lot. I've seen a lot of startups in the past just 6 months, and it definitely seems promising. Obviously, it's a very new concept in a very new industry, and there's a lot of experimentation going on. I'm personally also sort of working on projects around the same area, but to give more perspective, I think I'll just show like 2-3 images that will sort of help, which I took out from some blog, which will sort of help people understand a bit better, I guess. So I'll try presenting my screen. Yeah, I think it should be visible. Yeah. So why do we use the word regenerative? It's because two things. I think the biggest thing right now is climate change is an actual threat that we've already come across in the past 5 years, that the Earth's temperature is rising very rapidly, and the reason for that is obviously the amount of emissions that have happened over the past century. And how we can sort of effectively solve this is by achieving a net zero economy, and that's what a lot of countries have sort of tried to, like, at least have an agenda of doing, where they do in all these international UN conferences. But then we would need more effort from like each individual citizen and like corporations and everyone to sort of achieve that goal. And that's where we sort of that's where regenerative economics is, where we sort of take back that money, a part of that money, and sort of assign it to a project that helps offset all those carbon emissions that are out there. So you can see this is how regenerative economy works, where whatever profit is done, a part of it is pumped back into the ecosystem of like either preserving natural assets or investing in clean energy, or any of these that will help sort of reduce carbon emissions. Whereas this is the current model of extractive economies, where you take out the resources, it might be hardware, software, you produce some meaningful outcome, and then only the very few top people get to keep all the profits. And that's why partly that there is so much wealth, inequality of wealth distribution all around the world. And also like the fact that we are in this current place right now, that there is so much emission that happened during the industrial revolution, shows that we really didn't think past through like generating profits. Even now businesses focus solely on generating profits than the impact they're having on the environment, or any other kind of impact they might be having on the planet.
Basically we just talked about sustainable development, and it stayed in the books and theory, and it never implicated in our action.
But now we'll sort of have to look into it, because it sort of threatens our existence. And how and this Web3
I think it's high time that we take an action, because it's already too late.
So this is where sort of Web3 comes into the picture, and these are sort of the traits that allow it to sort of they both like solve those problems which this climate specific things that in the Web2 technology world actually face. So things like transparency, decentralized, censorship resistance, and being accessible to everyone. Because a lot of the even though if these carbon credits were sold, they were like I mean, it's not accessible on the internet. It's not free for everyone to go and get it. Like it's
Yeah.
very nobody even knows about it.
In
That's
fact,
how
even it was not like there are very different kind of like people who are issuing that, organizations that are issuing that. So it is
Right.
very difficult to even keep a track of how many carbon, like this the whole tracking of carbon offset thing. I don't think it was much like significant till now.
Yeah.
Yeah.
So it's for like there's a general lack of awareness and understanding of how it works and all these things that lead to sort of ignorance of how to use them. So that's where like sort of Web3 comes into the picture and sort of helps in that sense. And what ReFi extends from Web3 is some of those same concepts like accessibility, and then also that these credits can sort of be globally. If it was a private company, it would sort of be under the jurisdiction of that country, and it would have certain limitations and rules and all those things. But in case like if it is on blockchain, then there is a possibility that it increases accessibility to sort of buy those carbon credits more easily, and then you don't have to go through all the laws of that particular country. So that's what it
Censorship resistance,
yeah.
basically.
So basically it reduces the friction and like the flexibility that allows you to make this impact.
Yeah.
And that's why like, blockchain is a very good this is a very good use case for blockchain is what I feel like.
Yeah.
Compared to everything else that was out there like NFTs and all that,
Yeah.
they
Seems like some real big issue that the blockchain was suited to solve.
yeah. So that's what like a lot of we saw a lot of like NFTs and all that, but there was I think the in the past 2 years what Web3 has lacked is the real world use cases. I think now that's
Yeah.
slowly coming out into like, well, how can we actually use this technology to make some meaningful goal or meet some meaningful criteria.
Yeah.
So that's what ReFi is about. And the place I would, if you want to learn more about it, the place I would suggest you to start is token.earth blog. So Token is a company and they deal with all this carbon credit stuff, and they have a very good blog explaining everything A to Z about ReFi. They have a lot of blogs, a series of blogs to sort of help you understand how it works behind the scenes. And yeah, once you get into Token, you will find links to other companies doing the same. And also there are a few hackathons also that go around the same concept. Recently it's been more popular. ReFi hackathons have been happening. There was one that happened in India as well. This I think the first ever ReFi hackathon that happened. So yeah, it's a new opportunity to sort of grab a new place to start. So yeah, I would recommend everyone to check out. And if you really sort of vibe with the mission, and if you see how threatening it is to sort of live in a world where your life itself is a question mark, so that I think would sort of resonate with us to make some kind of contribution. Either
It's like an opportunity for us to give back to the community and the world.
Yeah, exactly.
And I think it's high time that solutions like this, I mean, like people start working on solutions like this, because we are already facing the consequences of our actions, and God knows what the next generation is gonna face.
Exactly. So I think definitely there will be a lot of security issues, especially like food security. We are already seeing it because of the war. So food security and then trade and all these things will be so polarized and mobilized in the world. On top of that, there will be a climate crisis. So it's not a very the very foreseeable future is not a very hopeful thing, and we should sort of prepare. Try to bring out as many positive things as possible, I think. And yeah, I think blockchain is a cool piece of technology that has come out in the recent decade to bring out these use cases into more effective ways, I guess. So yeah.
And I think it's a great time to invest and basically to accept blockchain and start as a developing in blockchain. Why? Because we are basically the early adapters of blockchain, and we are the first generation of developers. And we have seen that it's always the case that the people who are early adopters have a huge advantage over others, if we see for the personal advantage and personal growth perspective. there's a lot that is broken in Web3 right now, and there's a lot of stuff that is still under development, and that's the thrilling point of Web3, that you get to work on the real stuff. You get to build something that has never been built before. So in case of Web2, you will see every day some new organization will come and they will say, like if you have Silicon Valley, they say that we are making this and we are going to make the world a better place. That line, making the world a better place.
Yeah.
So every other company is basically doing the same thing, and they are just advertising in the name of making the world a better place. Here in Web3, there are real world problems that you can address using Web3. And it comes in a lot of forms. What we all discussed over here, basically we discussed the use cases of public blockchain. There are private permission blockchains. These are already under use. So one example, if I want you to look into, is the Spunta project. So that's something that I recently looked into. And what it did is that it was a huge revolution in Italian banks. So they used R3 Corda blockchain to further data reconciliation between the different banks of Italy, and they reduced a lot of auditing overhead and time that they had to spend in manually reconciling their data in case of conflicts. So that's one big use case, and that's a problem that was solved by a permission blockchain. So blockchains are like everywhere right now. Sometimes people are skeptical that this is an early technology and something that would be trending in the future. But blockchain is present. It is happening in the present. If you want to get into it, this is basically the best time to get into it. That's what I would like to say. So, anyone wants to say anything in the comment section? We are basically reaching towards the end of the event. So I don't think anyone has anything to say. Okay, thank you all for joining. Thank you, Samir Kashyap, and thank you, Samir, for joining here and sharing insights about blockchain and stuff. And
Yeah, it was wonderful.
Let's meet in the second episode of this event. And thank you all again for joining. Have a good night. Bye-bye.
Yeah, thanks guys. Awesome event. See you.
Thank you. Bye bye.